For this question, we are talking about the cylinder, and then so we draw a cylinder on the paper, and then set height as h, side radius as r, and then the question talk about that the cost for the side, which is here, is $8 per meter square, and the top and the bottom cost $10 per meter square, and then we need to find the equation at the beginning, which it talks about the can hold 20 pi. So we have a volume equation. The volume equation for the cylinder is pi r squared times h equal to volume. And then we put 20 pi into the v, so and then replace h by them. Just 20 pi divide pi r squared, and then cancel the pi, so it's 20 divide pi r squared. And then we find another equation. Because of that is like $10 for each per meter square. So I think we need to find the arrow equation. The arrow equation for the cylinder is equal to 2 pi r squared, which is bottom and which is the arrow equation for the bottom and top, and minus h bracket 2 pi r bracket. This means that the side arrow, and then we need to put the cost into the equation so that can make the highest cost, and I mean not highest cost, the most economic one. So replace it just to c, which means cost, and then 2 pi r squared times h, because it costs 10, times 10, and then my plus h break 2 pi r break times 8, because it costs 8 for the side. And then we do it, and it's like 20 pi r squared minus 20 plus r squared times 16 pi r. Cancel the r, so it's 1 r. And then we do the derivative of the function, which equals 40 pi r minus, because if this r as denominator, so it equals -1, which means we need to put -1 in front of this, so it becomes minus. So it's 320 pi r -2 to the -2, and then we factor that out, so 40 pi break r minus 8 r squared, and then so this is equal to 0, so r minus which this equation should be equal to 0. Then I got r to the 3 minus 8 divide r squared equal to 0, so r equal to 2, and then we put r into this function, this, so we can get h, and so h equal to 20 times 4, divide by 4, so equal to 5, and then we can find out the cost for the total. So these values are the most economic cost. So we put the equation in, so it's 80 pi plus 160 pi, which is equal to 240 pi. For this question, we are doing a rectangle equation problem. So the equation for this problem is supposition equal to t to the 3 minus 6t to the 2 plus 91. And then the A asks about the velocity function. Velocity function is equal to the derivative of position function. So it's velocity function equal to the derivative of position function, which is equal to 3t to 2 minus 12t minus plus 9. And then we need to set this to 0 and factor this out. So we can put into the calculator the program and do the quadratic formula. 3, negative 12, and 9. It's 3 and 1, which means t minus 1 times t minus 3. We need to put 3 out, equal to 0, and t equal to 1, and t equal to 3. And it also asks about the initial velocity, so which means we need to set this t to 0. So v0 equal to 9. And then we can do a number line 1 and 3 to find out whether it's gonna be from the left or right. So if we put smaller than 1, so it should be positive. And see the exponential is like odd number, so it's gonna be positive, negative, positive. And then it asks about when it stopped. So it stopped at 1 and 3. Yeah. And then B is asked about the acceleration function. Acceleration function is the derivative of velocity function. So we can have a function like this. Velocity, derivative of velocity function is equal to 6t minus 12. And we set this equation to 0, which means t equals 2. So it changed the acceleration at 2. And then we have a number line too. This is 2. And then we see, so it's negative and positive. And it also asks about the initial acceleration. So it should be 8, 0 is negative 12. C is asked about when it's gonna slow down and when it's gonna speed up. So we should have a number line to find out, to justify our acceleration. So this is the number line, make it bigger. This is for velocity. This is for acceleration. Okay. 1 and 3 and 2. And we can make a line to see clearly. Should be here. And then before 1, smaller than 1 is all positive, as we see here. And greater than 1, smaller than 3 is negative. Greater than 3 is positive. And this is negative and positive. So it slowed down. Use another pen. When it slowed down, it should be slow down is, this is slow down, speed up, because it's the same sign, so it should be speed up, and this is slow, and this is speed up. Okay, so maybe you should write a to clarify that. So when it slow down when t is less than 1 and 2 less than t less than 3. Speed up when 1 less than t less than 2 and t bigger than 3. Okay, so this is for the C, and let's look for D. So D is talking about how the total distance traveled from t equal to 0, then t equal to 5. So we need to find their position. So we need to plug 1, and 3 into the original function here, and then we can see. So when we plug in there, when we plug 1 into there, it should be equal to 5. So it should be like S1 equal to 5. And when we plug the 3 in there, it should be S3 should be equal to 1. And maybe we should find the into position. So which means S plug 0 into t, which means equals to 1, 2. And then we can find we can use and also it talks about when it's gonna end at t equal to 5. So maybe we should put t equal to 5 in there too. So it should be when t equal to 5, it equal to 21. Okay. So and then we can make a number line for this, so it maybe will be clear. A line like this. Make a line. Just for sure, just write the numbers again. S0 is 1. S1 is 5. S3 is 1. S5 is 21. And for this reason, when the acceleration change, maybe we should put 2 in there too. So S2 equal to 3. So the into position is 1. So this is 1, and t should be equal to 0. And then when it goes to 1, the speeding is slowed down. So it should be like this. Stop here, which t equal to 1. This is 5. And it goes to the left after that, which means it goes like this. And stop, not stop, like change the acceleration at 2. 2 should be about here, 3, and this should be t equal 2. And then it's slowed down again until 3. 3 is equal to 1, so it's still here. T equal to 3. And the last step is 5. So 5 is until 5 is speeding up until 21, just like here. And then 5. So this time it ends and it's equal to 5. So the total distance here to here is 5 minus 1, so it's 4. And this is definitely 4. And then this distance is 21 minus 1, which is 20. So the total distance is equal to 20 plus 4 plus 4, which is equal to 28.